Black holes are among the most mysterious and scariest objects in the universe. Thanks to the amazing, painstaking efforts of scientists who have dedicated their lives to studying black holes, we now know a lot about these infinitely dense abysses. Chances are you won't come across anything weirder than a black hole, and here are some mind-blowing, scary facts to prove it. A black hole is practically invisible. Nothing can escape the massive gravitational pull of a black hole, not even light. Hence, there are no photons that are reflected, which can then be used to image the black hole as an object. It's called black hole for a reason after all. That's not to say that we can't detect them. Astrophysicists use proxies like the stream of matter and energy pulled from a ripped-apart star, for instance. The gas molecules start swirling around the black hole in the form of a disk and emit powerful X-rays. Black holes can also be detected by watching for motions of stars near the black hole, a hungry monster in every galaxy. Over the past 30 years, observations with the Hubble Space Telescope have shown that all galaxies have black holes at their centers. Bigger galaxies have bigger black holes. Nature knows how to make black holes over a staggering range of masses, from star corpses a few times the mass of the Sun to monsters tens of billions of times more massive. That's like the difference between an apple and the Great Pyramid of Giza. Our local black hole is located in a region known as Sagittarius A and lies around 26,000 light-years away from the solar system. Thankfully, that's comfortably far away. It's about 4 million times the mass of the Sun, which in turn is about 1 million times more massive than the Earth. Just last year, astronomers published the first ever picture of a black hole and its event horizon, a 7 billion solar mass beast at the center of the M87 elliptical galaxy. These black holes are dark most of the time, but when their gravity pulls in nearby stars and gas, they flare into intense activity and pump out a huge amount of radiation. Black holes are anything but empty. Don't let the name fool you. Rather, think of something immensely massive packed inside a very small volume. For instance, a star thousands of times more massive than the Sun squeezed into a sphere approximately the diameter of New York City. The result is a very strong gravitational field from which nothing can escape, only a more massive black hole. But even then, the latter would eat the former. Black holes can reach gargantuan proportions, but could also be as small as a photon. Black holes are classed into 3 types based on their mass as follows. Stellar black holes. When a large star runs out of fuel, it may collapse into a black hole. All black holes start out small, then grow in size as they consume matter from around the galaxy. Supermassive black holes. Ranging from hundreds of thousands to billions of solar masses, supermassive black holes can form in a number of ways. For one, a small black hole can be fortunate enough to come across a large gas cloud. Hundreds of thousands of tiny black holes may also merge to form one mammoth hole. Finally, a stellar cluster, which is a group of many stars, can all collapse together to form a supermassive black hole. Intermediate black holes. It's only recently that astrophysicists from NASA found that there are black holes with masses in between stellar and supermassive varieties. These mid-mass black holes were first discovered in 2014 and contain the mass of a few hundred to a few 100,000 suns. Primordial black holes. These hypothetical black holes could have formed shortly after the Big Bang following energy-particle interactions. As such, they imply a completely new mode of formation, different from the collapse of stars that birthed the black holes we all know. NASA says these black holes act as dark matter. Hypothetically speaking, the smallest black hole might be the size of the Planck length, the smallest anything can be. Objects falling through a black hole become spaghettified before disappearing into oblivion. At the very center of a black hole is the gravitational singularity. It's a one-dimensional point where a huge mass is squeezed into an infinitely small space. Density and gravity become infinite, and the space-time curves infinitely. That's a lot of infinity, enough to make your head go dizzy. In fact, not even the laws of physics can stand that much infinity, apparently. As American physicist Kip Thorne puts it, the singularity is the point where all laws of physics break down. Equations crunched so far suggest that an object falling into a black hole becomes spaghettified or stretched out as it nears the singularity. If it was you who was falling inside the black hole, you'd be able to see distorted images as light bends around your point of view. Eventually, the ripped-apart object loses dimensionality completely and disappears into the singularity. Black holes don't suck. In fact, they're oddly awesome. Smug replies aside, there's this common misconception that black holes act as a huge vacuum cleaner of sorts. While it's true black holes can pull matter in at incredible rates, it's all due to gravity, not some mysterious fan. If you were to replace the sun with a black hole of equal mass, theoretically speaking, everything in the solar system should orbit as usual. Black holes can stop time. Were you to wear a spacesuit that would render you immune to the gravitational pull of a black hole, you would see objects passing through the black hole's event horizon appear to slow down, then freeze in time. In other words, it's as if they had never passed through the event horizon. That's because the space-time is distorted, and the light takes longer to reach your telescope's glass. In fact, it takes an infinitely long time. As time elapses, the light subsequently becomes red-shifted and dimmer as its wavelength becomes longer, eventually disappearing from the sight of the observer as it becomes infrared radiation, then radio waves. Black holes might be able to grow infinitely large. Black holes can keep growing because anything that enters the event horizon gets sucked in. Theoretically, a black hole can grow indefinitely. However, there's evidence that suggests that ultramassive black holes found in the cores of some galaxies never seem to exceed 10 billion solar masses. Recent studies suggest that black holes may not physically grow beyond this mass because they would then begin to disrupt the accretion disks that feed them. Black holes might be wormholes. A wormhole or a Lorentzian wormhole is a sort of theoretical tunnel through space-time, often used as the preferred mode of interstellar travel in movies like Star Trek. The opening is a shortcut through intervening space to another location in the universe. That seems to be in stark contrast to a black hole, which is less of a funnel and more of a meat grinder. However, some physicists claim that there are many characteristics which both black holes and wormholes share. Perhaps a wormhole is a black hole and vice versa. Black holes might spawn new universes. Our very own universe that we hold so dear might have actually been birthed by a black hole, and the billions of black holes in the universe might, at their own turn, each spawn their own versions of the universe. As mentioned earlier, in the singularity the laws of physics break down. Some physicists speculate, however, that they actually are reborn again in a baby universe. According to pioneering physicist Lee Smolin, a star that collapses into a black hole very quickly squeezes down to infinite density and time stops. That's according to general relativity. And basically that moment when time stops is deferred by quantum mechanics, by quantum uncertainty, and rather than collapsing to infinite density, the star collapses to a certain extreme density and then bounces back and begins to expand again. and that expanding star becomes the birth of a new universe. The point where time ends inside a black hole becomes joined to the point where time begins in a Big Bang in a new universe. That's all time we have for today's video. Like this video if you found it helpful, and don't forget to press the bell icon so you won't miss any updates.